Hi all, Ms. Z here, and today we have a quick review with arrow notation on translations. So our essential statement is I can use and read arrow notation. And we have a couple of examples for you today in regards to that. So I'm going to go ahead and open this up. Here you see an example of something that you might see in your classwork or your homework. You have two figures, two quadrilaterals, okay? Quadrilateral TUVX, and that's being translated to TUVX prime, okay? I know this looks like a lot of information, but go ahead and pause the video and write this down. So I also wrote out the points for you, TUVX, right here. We have all of those points, and they're being translated to these points right here. And the reason I wrote out the points for you is so it's easier for you to plot your quadrilaterals before you do the problem. Now, the rule states, or actually not the rule, but the question asks you, state the rule of the translation from quadrilateral TUVX to quadrilateral TUVX prime, okay? And how are you going to use arrow notation for this? Well, you're going to start with your ordered pair, x comma y, and then you know that you're going to have something like this. You have an x here, comma, and a y here. And you close your ordered pair. Now I want to add something over here. If you think back, remember for x, plus is to the right, minus is to the left, and for y, plus is up and minus is down. So pick a point. Let's start with our first point, t. Am I going to move right or left to t prime? Well, I'm going to be moving right, and then count how many to the right. 1, 2, 3, 4, 5. Okay, then I'll stop there. So I'm moving 5 to the right. Right means plus, so that's plus 5. And then I'm not done yet because that's not where t prime is. So I still have to move up 1, 2 to t prime. Up for y is also plus. And that's it. There you have it. But you want to double check the rest of your points. So let's look at x. Okay, 1, 2, 3, 4, 5 to the right and up 2. Perfect. Okay, 1, 2, 3, 4, 5 and up 2. Perfect. So all of your points should all be moving to the right 5 and up 2. But we want to write it in arrow notation. So first, if you would like, you can find what the translation is in words. So in this case, it was right 5 and up 2. And then all I did was I changed the sign of the word. So right means plus and up also means plus. So my ordered pair, x comma y, goes to x plus 5, y plus 2. Now, another way that you can double check this is if you look at your points right here, let's look at t, okay? So if I do -4 plus 5, I should ideally get 1. And -4 plus 5 is 1. And then if I do 0 plus 2, I should get 2, which is correct. So you can check your points that way as well. But this is what we were looking for right here. Okay, we'll do one more example. So let me move this up. Okay. So here we have state the rule of the translation from PQR triangle to triangle PQR prime. So this one's a little interesting because it's only moving in one direction. So let's go ahead and start with our ordered pair x comma y and then see what happens to one of the points. So remember, you always move right or left first. In this case, to get to q prime, I don't move right or left. So x stays, let me write it in words, x stays, but then the y goes 1, 2, 3, 4, 5, 6, 7, 7 up. So how do I translate these words into arrow notation? Well, If x stays, that's kind of like writing x plus 0, but we don't really need to write plus 0, so we just leave the x. And then the y, up 7, up means plus, go plus 7, and you're done. Now what you could do is you could also write out the points for triangle PQR and triangle PQR prime, and then see if this rule works out for those points. And that is how you read the graph and write the arrow notation of the translation.